Desk Ladyada.
Hey everybody, it's Desk Ladyada. I just realized I actually have to grab my camera thing. Do you want to give them the news, Mr. Ladyada, while I grab my camera sample?
Yeah, I will.
Okay, I'm going to eject.
All right. This is the, what they call in the biz, dead air. Anyways, during the week, we have our shows. Now I can announce it. Everybody's back. So we have Tuesday, JP Product Pick. Wednesday, Noam Pedro, 3D Hangouts. Show and Tell, Ask an Engineer.
Yeah.
JP's Workshop on Thursday, Deep Dive with Scott.
Yeah.
Okay, we're back.
Okay, thanks. Sorry, I forgot that I have to grab my camera. I'm going to show off my camera stuff that I was demoing. We did a little video, but I thought I'd show the camera.
Yeah, we have a bunch of videos we'll be posting throughout the week. We have samples and more and stuff from the mailbag today.
Yeah,
all right.
Tons of stuff.
Show them off. What do you got to do?
So let's start with camera. So we're rounding the bend of all the camera stuff that we've been trying to do. We've been trying to add camera support for like cross-platform RP2040, ESP266, and SAMD51 to CircuitPython, and also to Arduino as well. Camera's one of those things where it's like there's always like example code for using a camera with a microcontroller if it has a camera peripheral, but it's always like it just supports that camera and just that resolution. It's like, oh, really like tough to use in my opinion. So we wanted to make something a little easier so that we could actually start doing either like machine learning or like vision recognition or just like image capture for microcontrollers.
Yeah, we're gonna have, I think, one of the best, first, easiest to make your own digital camera. I don't see any of them out there like that, but we're going to do it. It'll be the easiest to make yourself your own digital camera.
Yeah.
Do stuff. Just like you can make your own keyboard. We're going to have a lot of things like that.
Okay.
So you want to show this off?
I do, but yeah, here you go. So,
all right.
Okay, so let's go to the overhead.
All right.
And I'll tilt this like this, which is going to be a little bit weird. Okay.
Yeah.
So
That's fine.
You can kind of see me. Hi.
Yeah, it's real.
Okay, so this is actually running in CircuitPython, which you can see when it boots up. It has the little CircuitPython thing. I forgot the one thing that's a little bit annoying about the Kaluga, this is the Kaluga kit, is that this USB is not the native USB, it's FTDI USB, it's like the debugger. You actually have to connect a USB pin out or break out to one of these GPIO pins to get USB. So I'm not going to show you the code, but this is, and you can see me, hi, hello. This is me going through this camera, which is an OV2640, which is kind of like the modern camera module that people use. These modules are only a couple bucks a piece, and they come with a little flip top. So they're easy to use. We added support for the OV7670 like a month or two ago, about 4 to 6 weeks ago. The OV7670 is like the older camera, which is not as modern. One of the nice things about the OV2640 is first, you can get it now. It comes in this little mini module version instead of like this gigantic chunky camera that needs a lens. Like, so this is all lens inclusive. You can just use it as is. And it has like some funky things built in, like JPEG mode. Like you can actually have it encoded JPEG and download it. So it's an all-in-one camera module. And so in this code, what we're doing is we allocate a buffer. Like, so the nice thing about the ESP32S2 is it has like that 2 or 4 megabytes of PS RAM, and so we can buffer a whole 320 by 240 bitmap image that comes from the camera, and then we blit it out to the screen. So it's not super fast, but there's not a lot of optimization that we've done yet. Like right now, we're like halting the whole system while we read from the camera because we have to do this you can't DMA from the camera because you can only DMA to the internal memory, and there's not enough internal memory, so you have to DMA and then computational buffer and So, it's not super fast, but this is 320 by 240. Probably in a preview mode, we'd actually do a smaller resolution, so it's maybe a little bit faster. But it just shows that you can do 320 by 240, and this is great. I mean, this is really good quality for just like CircuitPython with an external camera peripheral. So Jepler wrote the code. I only tested it. I didn't do anything with it. But he got through it all, and we just merged in the changes. So CircuitPython 7 is going to have native camera support. So if your board has a camera peripheral, like the SAMD51, ESP32S2, or the RP2040, which has the PIO camera, you can fake the camera peripheral with PIO. You're rocking. You can do camera stuff. So that's pretty cool. I'm very excited for that.
Okay, what else? What's next?
Okay, thanks for being patient with the demo. So the next thing is I did some playing around with, I'm still on the Keebs. So let's go to this. So this is a Geek Hack 60 compatible. It's called the MJ61, but it's like a 60% keyboard. And it's got sockets and LEDs. It's actually kind of a nice board. I want to make something that's CircuitPython compatible. And this looks familiar. Right? I didn't have all the keys in, but you can see the keys snap into place here, and there's a little RGB LED that comes out of here. And if you look carefully, you'll note that the RGB LEDs, let's see if I can get it to focus. The RGB LEDs are not neopixels. You can tell because there's no like black dot in the center of them. That would be the chip. These are just actually raw RGB LEDs. I think I even maybe showed this board off a few weeks ago. And here's the controller chip, which is a STM 32F303. It might be able to run CircuitPython barely, but we don't have a ton of support for the F3 series. This is a Cortex M3, and because these are LEDs that are not neopixels, they're not smart LEDs, each one is actually addressed individually, and it's done by this chip, right? This chip is the ISI 31FL3741. This is a handful. This is a LED I2C to LED driver chip that has all the PWM dimming you need for a matrix of LEDs, and it can do 9 by 39. So total number of LEDs is 351. Usually you have 3 LEDs per RGB LED, right? You have red, green, blue, so you divide that by 3, so it's like 112 or something, which means it's common for a lot of keyboard projects to use this chip because it can control about 110-ish LEDs, which means it's a full keyboard, 1 LED per keyboard driver. So that's that. So that series of chips, the IS31FL3741 may sound familiar. It's very similar to the chip that we've used in our Charlie Plex wing, right? So this is a monochromatic LED driver I2C chip over here, and it can drive 144 LEDs. Again, you could divide it by 3 for RGB. In this particular case, although I think it's actually Charlie Plex, so in this particular case, it's good for monochromatic LEDs, but you can see that they do dim, right? This is an on-off. It has 8 bits of dimming per LED, and it does do it for you. So you just set the memory buffer in I2C, and it goes ahead and it does the rest. So, and Phil, you wanted me to show this off.
This came in the mailbag. This is from Trevor Flowers from Transmutable Goods, and I'll put the links in the chats. And here's it's a kit. It's all open source.
This is so bright. I gotta move this out of the way. Yeah.
And this is what you get, the kit.
Yeah, it's a 3D.
That's what it looks like. Yeah. And do you want me to show it off again?
Yeah, let's show it off.
Yeah.
So it has the feather on the bottom, and it has even a little slot that you can
I want to
plug.
try to focus in on that. We got a lot of LED stuff going on tonight.
Yeah, it's kind of freaking out constantly. And then on the top, you can remove this.
Yeah, it's cute.
Insert the feather wing, so it's like a nice little desktop.
Yeah.
Desktop front. Good if you have an OLED or something, or display.
Sometimes folks send us things with the things that they make based on the things that we've published. That's kind of nice.
Yeah. So I got so I'm interested in this IS31FL3741. This is a really long part number. So I got an eval board, which of course now just isn't. I unplugged something. What did I unplug? Or maybe it just needs to be reset. There you go. It just needs to be reset. So let's go to the overhead. So this is a.
I'm trying to.
And
focus in
there's so
on that
many
one.
things I got to do here. So I just thought maybe I would put this on top.
That was a little bit. It's trying.
It's trying. Okay, so it's bright. Of course, it's legible if you're a human. Cameras don't like it so much, But up here I've got my Metro Mini, and it's connected over I2C to a dev board with, it's 13 by 9. That's like the number if you divide by 3. It's 13 by 9 LEDs, RGB, so you can see like each color. This is a gradient down here, so it goes from dim to bright, and then it's got the colorful Adafruit. It's doing some text scrolling because I got it working with GFX. This dev kit actually comes with also an STM chip, but you can remove the jumpers quite easily to make it so you get access to the I2C, so you can send data over it. And I published the repo, so if you want to use this chip, you can. So I'm probably going to start with making a breakout for this chip, or maybe an RGB matrix for this chip to try it out. Like I've got the eval board, so I know my firmware is good, but I have to find an RGB LED that's small enough that I can use it in a keyboard, surface mountable, and also make sure I've got the package for the LED and all the peripherals going well. So I thought I'd do one last thing before we head into the great search and show off that we did get our, I'll just turn this over. I got our macro pad PCB.
Getting closer.
Getting closer. So
Space
we're going to
theme.
start fabbing this, so people have watched me build this. So we're doing keyboard stuff, and this is our first keyboard. We're starting with a small one, 3x4, with an OLED here over this kitty space person, space cat, and then a rotary encoder, 12 keypads with sockets. They can plug them in. So the Adafruit macro pad is coming to life. All right, so
Yeah, one question. Are those analog RGB LEDs?
yes, they're analog RGB LEDs. In
All right,
fact, we'll
that was a
talk
question.
about that in a moment.
Okay. All right, do you want to do the research now?
Yeah, if there's no other questions, let's head right in.
Yeah, we're going to do that.
Where in the world is that part I need? The great search with DigiKey.
Every single week, Ladyada does a great search. Brought to you by DigiKey. Thank you, DigiKey. And Ladyada uses her engineering skills for good and shows you how to find things on digikey.com. Ladyada, what is this week's great search?
Okay, so this week's great search, I just talked about how I'm working on keyboard design. So let's go to the overhead real fast because we're going to split this off. So it's good for me to show this. So this is a keyboard PCB, people who make mechanical keyboards. Each key has an RGB LED underneath it, which looks like that. And the RGB LEDs here are analog RGB LEDs. They're not digital, they're not smart, neopixels, dot stars. These are plain, one anode or one cathode, and then RGB, that's 4 pins total. And they're driven by this chip here, which is the ISSI IS31FL3741, which is a 351 39 by 9 LED matrix scanner driver, PWM driver, so that this will be able to control each of these LEDs, and you can have up to 112 or so LEDs, analog LEDs controlled by this matrix driver. So you're probably wondering, and here's the dev board that I've got for this chip, the IS31FL3741. That chip again here, this is a STM. Sorry, this chip over here, this is a little STM helper driver. So this chip, is designed to drive large LED, 120 LEDs with full 8-bit PWM per channel. Okay, so folks who know Adafruit are probably like, why use analog LEDs when you can just get NeoPixels? You don't need a driver chip. You don't need to route all the lines. You don't need all the, you just send data over one pin and you're done. Well, let's go to the computer and let's do some math. So the reason why we might want to use, here's just showing you the matrix driver and how it works. Why would you use a chip that costs $2 and then analog LEDs instead of just NeoPixel LEDs altogether? And there's nothing wrong with using NeoPixels. Go for it. They're totally cool. However, NeoPixels cost, about 10 cents a piece. And if you do the math, let's say you have, 100 keys on your keyboard and you're doing them with NeoPixels. So times 10 cents a piece. That's like the best price. If you're getting, reels and reels of them, you're going to get as low as 10 cents. You're going to spend $10 just on the LEDs, which isn't bad, right? If you have a very nice keyboard, you want one LED per key. However, once you get to these large quantities, the price of analog LEDs, you might be able to make it up, but even though you have an external driver. So if you have 100 LEDs and your analog LEDs cost 4 cents a piece, which will show some of them are even less, but let's say, your large quantity is 4 cents. Okay, $4, that's still a bit, because you have to add in the $2 driver, but you're still ahead by $4. And if you're making a lot of these, a lot of this product, and you have a lot of LEDs, you can see how once you get to like about 64 LEDs-ish, it starts to turn into, you might be better off getting a driver chip. Especially if you can get all of the LEDs driven by one chip, right? You get one chip, it's $2. Yes, that's your setup cost, but then each individual LED is only 2, 3, 4, 5 cents instead of 10 cents. And yeah, for something that only has 5 LEDs, I always go with dot stars and neopixels because they're so cheap and so easy. But when I'm thinking about a keyboard design or something with a lot of LEDs on it, I'm going to use a driver like this. So that said, we need to find a low-cost analog RGB SMD LED, which is what this great search is all about. Let's find these little friends here, RGB, right? And here's the thing. There are basically 3 kinds of RGB LEDs. You can have 4-pin common anode, 4-pin common cathode, or 6-pin where each LED is individual. These days, I don't see as many RGB. We do stock, RGB 50/50 plain LEDs here, and you'll see that these do have 6 pins on them because it's R, G, and B. There's 3 individual LEDs. However, I don't see these in the smaller sizes, so just be aware. It tends to be a common anode, common cathode, and this is kind of what I see more of these days. In this case, because of the way this is designed, common anode is more popular, and this is showing a common anode configuration, but you could use it with common cathode as well. That said, we're probably going to look for a common anode design, which means that, let's see, I think we have a couple common anode. Yeah, we have, common anode LEDs. This is a gigantic one, of course, but you'll see there's one positive, there's 4 pads, one positive, one red minus, one green minus, one B minus. So usually NPN transistors are a little stronger than P-channel or PNPN or PNP type transistors, and that's why common anode is a little bit better. Insignificantly, really, but it is a little bit better. So this is the driver chip again that we're using in case you're interested. They're going to have some in stock shortly. So let's look for RGB LED. So we're going to just search for RGB LED. And don't forget there's the addressable LEDs. These are the neopixels and dot stars and stuff. Good things. Here's like our favorite, the Jewel. But we don't want that. We want discrete. We want individual LEDs, non-addressable, analog. Okay, so I told you about the configuration. You can get, let's see, zoom in. We can get common anode, common cathode, independent or standard. What's standard, I don't know, but we're going to actually ignore that for now. Let's just start with, we just want active, and let's go with normally stocking, because right now there's a lot of stuff that's not in stock. So a lot of times I'm like, I only want to get stuff in stock if I'm getting a replacement part or a one-off. But because stocks of components are just so volatile right now, I'd rather see everything and then check what the lead times are. It could be reasonable. Usually LEDs are not. I don't think LEDs are strongly affected by the silicon shortage because they're not complicated transistor-based silicon made by TSMC. They're made more locally. They're made by smaller fabs. Okay. So next question is, do we want surface mount bottom entry right angle through hole? Well, I definitely don't want through hole. In this particular case, I don't want right angle or bottom entry, although I might eventually look for a bottom entry one just because I want it to, poke through the PCB underneath each switch. So I'm going to go with just surface mount. So already only have 200 options available. So the next thing is that everything else is kind of, I don't really care. Again, common anode, common cathode, doesn't matter. Cut tape or tape and reel. I mean, I'm going to eventually purchase tape and reel. Because I'm going to be using so many of these, I do want to see the prices at a very large quantity. So about 50,000 is what I'm going to put in for the prices. And then, so what I did for fun, which is sometimes my trick, is I sort downward by quantity. So for example, this LED, it's a very small LED, but you can see it's got 4 pads. This is, I believe, a common anode. And there's 2 million in stock, which is pretty cool. This happens to be a 1x1 sized 1 millimeter by 1 millimeter LED, which is a little bit small. I want something a tiny bit bigger. So I will show what the 1 millimeters are used for. So if we go to the overhead real fast. So this is a ultra. I mean, it looks like it's a texture, but it's actually, these are individual LEDs. These are 1 millimeter by 1 millimeter, I think, LEDs here. So they're used in LED panels. Also, sometimes I see them on dev boards as micro indicators. They're super cute, but this is a little bit too small for me. I want something a little bit bigger, a little bit brighter. So let's go back to the computer. So for dimensions, I think I'm going to go at least 1.4 squared. 8 by 8 is kind of big, but let's just do that. Okay, so we got rid of the ultra tiny ones. And so this one is kind of neat. This is actually a reverse mount one, which I thought was kind of interesting. But I think I'm going to start with, this size, which you can see there's a couple options that are very similar in size. I think this is this is 1.6 by 1.6, which is, a little, it's a bit bigger, but it looks like there's a couple different standard sizes for this. And in fact, if you look at the, hold on, let me go here. If we look at the overhead, so this grid, this matrix grid, this is that size. And I can even tell by looking at it, it's the same package. So this LED is similar to what was used on the eval board. Let's see if I can, this doesn't zoom in, right? Oh wait, what if I zoom? Oh yeah.
Yeah, you're zooming in.
Okay. So yeah, you can see these are a little rectangular. Okay, so let's go back to the computer. So I ended up deciding to go with this, and there's a couple things that I liked about this LED. One, it's nice and big, looks like I can even hand solder it. The other one, obviously, is pick and place only. This one, I like how you can, I could debug, solder this pretty easily with a fine tip. It has common anode connectivity, and the LED millicandelas are really high. So 630 millicandela for each one is, oops, I zoomed too much. 630 millicandela each is nice and bright. It means that even when I'm PWMing, it'll look really good. You can do global current control, so I can have a lot less current and still get a very bright light. Also sounds like, it says mixed white. I wonder if this is balanced, so that when all the LEDs are on, it kind of looks white, and it looks like these are binned as well. So this is a pretty nice LED, and again, it's 5 cents in quantity. So a good, if I'm looking at making something with 60 LEDs, like a 60% keyboard, adding these up and then including the driver chip could end up being a really good option. Another nice thing about these LED drivers is you don't write the entire number of LEDs at once, and also happens over I2C or SPI, so you can use DMA, and you can change individual LEDs. You don't have to write the whole thing out, which can speed up the system quite a bit, because you're just writing out like set LED to X, or set this other LED to Y. You don't have to write out the entire LED strip like you do with NeoPixels and dot stars. So pretty cool. I like that there's a couple options in this size as well, and there's 12,000 in stock, so I'm digging it. This is the B38 G3 RGB from Harvitech. There's a lot of LED makers, so looks like a jelly bean part, and I'm going to pick some of these up, and then you'll probably see these in a couple weeks when I design them into my keyboard controller. Very exciting.
All right, that's great, Church.
Where in the world is that part I need? The Great Search with DigiKey.
All right.
Yes.
And there are no questions.
Great.
Someone had something they want to check out in Discord, and I'll show you after the show.
Okay, cool.
That's about it.
All right, thanks everybody.
Okay, we'll see everybody during the week. We got all the shows going on. Thank you so much for supporting. I'm just going to say it until someone will actually meet on Twitter or something, but I think thanks for supporting the only 100% woman-owned manufacturing company in New York City. Yeah, sure. Okay. Oh, there is a question. Can that driver work with RGB W analog lens?
It'll
LED,
work.
sorry.
Yeah, it will, but you'll just get, of course, you'll have to do 4 LEDs per LED.
Oh, looks like tomorrow's solstice, so it'll be a long Monday. Longest Monday of the year.
Oh, that's great.
That's cool. Okay, we'll see everybody later.
Go outside.
Bye-bye.